Hi, my name is Ashwini Kumar and welcome to my channel. In this video, we are going to see this class 12 mathematics subject and the chapter 3. So here the chapter name is matrices. In this video, we are going to see the basics and definitions and a few examples regarding this matrices. And this concept is essential to solve the problems in the first exercise of this chapter. So the problems and the solutions of the first exercise we will see in the next video. So right now we are going to see the definitions and the basics concepts and the examples regarding this matrices. So before going into the details and all, if you are not yet subscribed the channel, then please do subscribe and then click on the bell icon. Then you are going to get all my videos, whatever I'm going to do the videos regarding the class 12 physics and mathematics directly as a notifications to your mobiles, laptops or desktops. Fine. So now while coming to the concept, so the first thing is a matrices. So a matrix is nothing but an array. So we can call this one as a multi-dimensional array. I will say what is exactly an array. If you are grouping the elements just like this, or else if you are taking any one box and just place the things or elements in this thing 1 2 3 4, okay, then we can call this one as an array. So for example, if you are taking an eggs tray, so eggs tray will be having like this. So if the 6 holes are there, we can able to place the 6 eggs in these holes, right? So that means all the 6 eggs are arranged in an array. So array means here, while coming to the matrix, we can arrange this array in the multi-dimensional way. Multi-dimensional way means here if you observe this egg tray, so it is a first array and it is a second array. That's why I'm saying this one as a multi-dimensional array. So generally the matrices are represented in the square brackets like this. Either it might be the square brackets or it might be the rectangular brackets, whatever it might be. So if we are representing in the square brackets, then it is called as a square matrix. Of course, one more specific definition is there for the square matrix that we will see later. As a starting, first we will explain the concepts in a simple way. And if the brackets are in rectangular way, then the matrix is called as a rectangular matrix. Fine. And now while coming to these, within these brackets we are going to place the elements. For example, if you are taking the egg tray as an example, eggs or comes under the elements, right? And this one is called as a, that means whatever it is there, it is a one horizontal thing. So this horizontal thing is called as a row, right? And now while coming to the this first one, this vertical thing is called as a column. So like that, a matrix can be defined with the help of rows and columns. See, if in this egg tray, here how many columns are there? It is the first column, it is the second column, and it is the third column. So total 3 columns are there. And while coming to the rows, how many rows are there? It is the first row and it is the second row. So that means here I am having the 2 rows and 3 columns are there. So now I can say this one as a 2 by 3. So it is the order of this matrix, or it is the order of this eggs tray. Okay, so it means 2 rows and 3 columns are there. So if I multiply this 2 and 3, what is the result? 6. That means this egg tray is having the 6 eggs, right? So 1 2 3 4 5 6. That means with the help of this simple example, that is the egg tray, we can able to explain the array, and this 2 by 3 is called as an order of the matrix. Okay, anyhow that we will see this order of the matrix later very clear. So right now we will be having few rows in the matrix and few columns in the matrix. So these combinations of rows and columns will build up a perfect matrix. And coming to the matrix, we're having the first one is a row matrix. If I'm saying any one matrix is a row matrix, so let's take this example 1 4 7. These are the elements and it is only one row, right? So one row is there, one row. And how many columns are there here? If you observe, it is the first column, it is the second column, and it is the third column, right? So but here I'm having only one row, so that's why it is called as a row matrix. That means a single row. So it is called as a row matrix or a single row matrix or one row matrix. And now what is the size of this matrix? The size of this matrix is, how many rows are there? One row. And how many columns are there? Three columns. So the order or the size of this matrix is 1 by 3. And 1 by 3, if I multiply 1 and 3, it becomes is equal to 3. So how many elements are there? 1, 2, 3. 3 elements are there. So that is this thing. So 1 is the one element, 4 is the second element, and 7 is the third element. So like that we can place. And if I say about the column matrix, then we have to write like this: 1, 4, 7. It is a column matrix. So why? Because it here it is having only the one single column. Okay, one single column. And how many rows are there? It is the first row, it is the second row, and it is the third row. So the order of this column matrix can be given as, first we have to write the rows by columns, right? So how many rows are there here? 3 rows are there. By how many columns are there? Only one column is there. So the size or order of this column matrix can be written as a 3 by 1, right? So like that we can justify the row matrix and column matrix. Anyhow, for example, if I'm taking any one square matrix with 3 by 3 order. 3 by 3 order means, what is this thing? This first 3 represents the number of rows. This second one represents the number of columns. That means I must have the 3 rows and 3 columns. So let's take like this: A11, A12, A13, and A21, A22, A23, and A31, A32, and A33, right? So what is the suffix represents means 1 1. That means it is the element in first row and first column. And here 1 2 represents it is the element in first row and second column. And 1 3 represents it is the element in first row and third column. In the same case here also, this 2 1 represents it is a element in second row and first column, and it is an element in second row and second column, and it is an element in second row and third column. And coming to here, it is an element in third row and first column, and it is an element in third row and second column, and it is an element in third row and third column. So for example, if I give any one matrix like this: 1 4 5, 2 minus 4 3, and 1 9 10, right? So if I ask you that what is the position of this minus 4, means the position of this minus 4 means generally we can find out it is the first row, and it is the second row, and it is the third row. So this minus 4 comes in the second row, right? And then we will see the column. So this 1 to 1 is the first column, and 4 minus 4 9 is the second column, 5 3 10 is the third column, right? So now this minus 4 is in which column? Second column. So we can write like that. That means it minus 4 is the element present in the second row and second column. So this minus 4 is equal to, as per, if I equate both these two matrices, then minus 4 can be written as a suffix 2 2. A suffix 2 2 means, as I told here, that the element present in the second row and second column. Okay, so just like that we can equate the matrix, or we can place, or we can mention the position of any one element that is present within the matrix with the help of this order, or with the help of this row and columns. So while coming to this example here, this is the two different types of matrices with respect to the orders. Here we can see that if you want to mention this order of this matrix, then you have to find out how many rows are there and how many columns are there. So it is the first row, and it is the second row, right? And while coming to the columns, that means how many rows are there? 2 rows are there. And while coming to the columns, first column, second column, third column, and fourth column. So we have to write the order of the matrix row by column. So first rows must be there. How many rows are there? 2 rows are there. And how many columns are there? 4 columns are there, like that. And here also, first row, second row, third row, and fourth row. So 4 rows are there. And how many columns are there? It is the first column, and it is the second column. So order must be row by column. So rows are 4 and columns are 2. So the order of this matrix is 4 by 2. So like that you can identify, or you can find out the order of the given matrices. So these are the different examples given here. So like that, here one more example is there. if a matrix has 8 elements, what are the possible orders it can have? That means if the matrix have 8 elements, what are the possible orders? See here, if a matrix has 8 elements means, generally I told in the previous concept that if we multiply the number of rows and number of columns, see in this case 2 by 4 is the order, right? 2 by 4, so just multiply both these two, how much will get? 8. That means here how many elements are there? 8 elements, 1 2 3 4 5 6 7 8. In the same case here also 2 into 4, so that means 8. So here also 8 number of elements are there. So that's what here they're asking in the question or in the example. 8 number of elements are there in the matrix, then what might be the order of the matrix, right? So the order of the matrix means if you multiply the number of rows and columns, you have to get again 8. So like that, let's take 1 by 8. 1 by 8 means how many rows? 1 row. And how many columns? 8 columns. That means we can get like this: 1 2 3 4 5 6 7 8, right? So here only one single row, and how many columns are there? 8 columns are there. So here how many elements we will get? 8 elements. So 8 elements, 1 by 8. In the same case, we can take 8 by 1 also, right? 8 by 1 means 8 rows and 1 column. So 8 rows and 1 column means the matrix will looks like this: 1 2 3 4 5 6 7 8, right? So it is the 8 by 1 order, and here also 8 a number of elements are there. So why? Because 8 into 1 is 8. And just like that, 2 by 4, why? Because 2 into 4 becomes is equal to 8. So 2 by 4 means 2 rows must be there. Let's take like this: 2 rows and 4 columns must be there, right? So it is a 2 by 4. Why? Because here 2 rows, first row and second row, and how many columns are there? 4 columns are there. And like that we can build up the 4 by 2, right? So how many orders we are getting? 1 2 3 4. So if 8 number of elements are there in the matrix, we are going to get the 4 different possible number of orders, right? So that is the thing: 1 by 8, 8 by 1, 4 by 2, and 2 by 4. So that is this example. And coming to the third example, construct a 3 by 2 matrix whose elements are given like this. And coming to this example, so construct a 3 by 2 matrix whose elements are, we are going to get the elements with this expression. So first, 3 by 2 matrix means how many rows we must have? 3 rows. And how many columns? 2 columns. So 3 rows means, first here I am taking A. So I'm just taking 3 rows, right? So first row, second row, and third row. And how many columns we have to get? Only 3 columns. So just stop with this only. So now we can see that here how many rows are there? First row, second row, and third row. That means 3 rows are there. So it is matching, and 2 columns must be there. So it is the first column, the center thing is the first column, and the center thing is the second column. So it is also matching. And now we will take the suffixes here: 1 1 1 2. That means first row, it is the element in first row, first column. It is the element in first row, second column. And 2 1 2 2 and 3 1 3 2, right? So third, it is the element in third row, first column, and it is the element in third row and second column, right? So now I got the 3 by 2 matrix with orders. So now if I want to find out this element, that means a suffix 1 1. So that means if I compare this a11 with respect to this one, I is equal to 1 and j is equal to 1. Now 1 by 2, 1 minus 3 into 1. That becomes is equal to 1 by 2, 1 minus 3. So 1 by 2 minus 2. So anyhow, 1 by 2 modulus means this minus 2 becomes a plus 2. This 2 cancels and I will get as a 1. That means in this place I have to put the 1 here, right? And next, while coming to the a suffix 1 2. A suffix 1 2 means if I compare both these two, in the place of I, what is there here? 1 is there. In the place of j, 2 is there. So after substitution, 1 minus 3 into 2, that becomes is equal to 1 by 2, 1 minus 6. So that becomes is equal to 5 by 2. That means here the first row and the second column element is 5 by 2. So like that you can calculate the elements of all this. So if you observe here this element, here I is equal to 2 and j is equal to 1, and here I is equal to 2 and j is equal to 2, and in this case I is equal to 3 and j is equal to 1, and in this case I is equal to 3 and j is equal to